I'm Wasja Bloch. I work as a postdoc at the Department of Earth, Ocean, and Atmospheric Sciences. I'm in Michael Bostock's group, which is the seismology group. The project is about the downgoing oceanic plate, and when it subducts beneath the continent, it bends open and water can infiltrate into the subducting plate. And I'm interested in measuring or estimating how much water is stored in the oceanic mantle when it subducts into the earth. So in my project, I analyze seismograms, so recordings of earthquakes. And these earthquake recordings consist of measurements of ground movement, which are like little wiggles and lines that you sometimes see in the media. And these wiggles can be interpreted, and I'm interested at one very specific wiggle. The amplitude of this wiggle and the timing of this wiggle tells me where there is a material contrast within the downgoing oceanic plate. And this material contrast, I think, is due to the hydration of the oceanic plate. And by measuring the properties of this specific wiggle, I hope I can find out how much water is within the downgoing oceanic plate. One main finding is that this specific wiggle I'm looking at just occurs over and over again at seismic stations. So I'm seeing it across the entire Cascadia subduction zone already, which is one subduction zone I'm looking at. The wiggle is on many stations. It's there, it appears again and again. I can reproduce it. Now I will start to quantify it, to estimate the material contrast. It's about understanding the inner workings of the planet, how this Earth is working, how plate tectonics is working, how the water cycles not only from the atmosphere to the ocean and back to the atmosphere over the rivers, but also deep into the earth and out of the earth again. So it's a very big and huge and important water cycling system that is little known about and that I want to find more about. I think the most fascinating thing was when one goes to the field and one goes to an outcrop and has the chance to lay hands on this layer, because on some places on Earth it's exposed. And if you just stand there and you're in the middle of 5 or 10 kilometer thick geologic unit and you think, okay, in my data it's just like a small wiggle and it's just a tiny anomaly I'm looking at, but on the real world, on the Earth, it's just a very big thing. And if you just stand there and put your hands on the layer, it's amazing. So next, I'm setting up an inversion method. I need to formalize the interpretation of the wiggle, because with this formalization, I can tell how thick the layer is, what properties it has. And I also estimate the errors on these numbers. So what's the uncertainty in the thickness of the layer? What's the uncertainty in the stiffness of the layer? Only then can tell what does this mean in terms of water content. The final result would ideally be a global map of subducting water, and this would be then a flux in the deep water cycle. So how much water per year is going down the trench into the earth mantle, and then this supplies then the asthenosphere, which is a layer on which the tectonic plates slide, and it also provides input to volcanoes. So this water then causes melt, and this melt comes up through volcanoes, and ultimately the water is returned to the atmosphere through volcanoes and outgassing in volcanic eruptions.